Hello students. Now the next property of the colloid which we are going to discuss is coagulation. Coagulation, which is also called as flocculation or precipitation. As we already discussed, the soles are stable due to the presence of charge on the colloidal particles. As we have already discussed, the particles have charges, and these charges, either it may be positive or negative, which is shown in the figure. Either it may be positive or negative soles. So these charged particles responsible for the stability of the sole, because of the equal charges, the particles repel each other. So that's why it will not come closer. That's why it will be quite stable. But when these charges are removed by some means, at the time it observed that the particles will come closer, because now there is no repulsion between them, since there is no charges. So the particles will come closer to each other, they aggregate, or we can say coagulate, and the particles start to settling down, and we can see that the particles all get settled. So this shows that the particles will get coagulate. We can say it is coagulate, or we can say it is get aggregate. The other word used here, that is flocculate. That is coagulation, flocculation or precipitation. All these words are related the same one. So we can say that when the colloidal particles lose its charges, then the particles come closer and aggregate or coagulate and settle down. So what is the definition for coagulation? The phenomena of precipitation of a colloidal solution is called as coagulation. And what is the other word used for this? Flocculation. What are the different means by which we can coagulate the soles? These are electrophoresis, mixing of two oppositively charged soles, boiling, persistent dialysis, and by addition of an electrolyte. So let us discuss these all one by one. Electrophoresis. This we have already discussed in the previous video. That is the movement of colloidal particles towards the opposite charged electrodes. Because of this reason, when the particles start to get accumulate at one end of the electrode, that means when the particles all accumulate at this end, we can say that the particles come closer. They come closer, and we can say that the particles get precipitated. So by providing an electric field, the coagulation can take place. The next is mixing of two oppositively charged soles. As we know that the soles are either positive or negative. So if this is a positively charged sole and this is a negatively charged sole, when we mix these two soles in an equal proportion, let here we have taken 1:1 proportion. In the equal proportion, when we mix this one, what happens? One will start to neutralize the other one. That means the charges get neutralized, because one having positive charge, one sole have positive, the other one is negative. So when it is mixed, one will neutralizes the other. So we can say that when the two oppositively charged soles are mixed in an equal proportion, it neutralizes their charges. And as we have already discussed, when the charges is removed, the particles will come closer. That means these get precipitated, or we can say get coagulated. Next is by boiling. When we boil the colloidal solution, which is shown in this figure, it observed that the adsorbed layer get disturbed. That means we have already discussed the charge on the sole is due to the adsorbed layer, which gives the charge on the particles. So when we do the excessing of boiling, what happens? This charge will get disturbed. That means the first layer get disturbed, and this reduces the charge on the particles and ultimately lead to settling down in the form of precipitate. So we can say ultimately when the charge get removed, it gets settled down. Where we have seen this type of example, the soles get coagulated on heating. One of the example, that is a coagulation of butter. In some cases, cooling can also result coagulation. Example, coagulation of milk. That means on cooling the milk, the fat present in the milk start to coagulate, or we can say flocculate on the surface. This maybe you have observed at home when you keep the milk in the refrigerator. After some time you will observe that the fat which is present in the milk, it flocculate, and you can find the layer of it on the surface. That is actually also coagulation. By persistent dialysis. Dialysis means the process by which the electrolyte particles can be removed. As the stability of the colloidal particle is due to the presence of a small amount of electrolyte. As been shown in this too, there are some small amount of electrolyte is present in a colloidal solution, and the stability of the colloidal solution, we can say, is due to the presence of small amount, or we can say traces of electrolyte. So if we remove the electrolyte completely from the colloidal solution by means of dialysis, it is observed that the particles left will get coagulate. That is called as persistent dialysis. By addition of electrolyte. This is one of the most important reason for a coagulation of the colloids. So let us discuss electrolytes. What is electrolyte? We have already discussed example like NaCl. These are the electrolytes which actually gives a true solution. So when we add a small amount of electrolyte in a colloidal solution, then it is observed that the colloidal solution, the particles start to accumulate and it get coagulated. Why it happens so? There are ions of electrolyte from which only the particular ion of the electrolyte, which is oppositively charged of the sole, neutralize the charge of colloidal particles. These ions are called as coagulating ion or flocculating ion or active ion. For example, if I take an electrolyte NaCl, if I add NaCl into the colloidal solution, what happens? Let this colloidal solution is of positively charged. So at the time, from this one of the ion, which is ion? The oppositively charged ion from the sole. That means if the sole is positive, the negative ion, that means Cl negative, it will neutralize the positive charge. So that's why it is said a particular ion of the electrolyte is neutralizing the charge of colloid. So which ion? Which is oppositively charged of the sole is neutralizing the charge of colloid. So such ion is called as flocculating ion. That means here from NaCl, which is the flocculating ion, Cl negative is the flocculating ion, if I am adding this to the positive sole. But if I have a negative sole, if I have negative sole, that means negatively charged colloidal particles in a colloidal solution, at the time which one will be the flocculating ion? Na plus will be the flocculating ion. A rule is given which is called as Hardy-Schulze rule. According to this rule, greater the valency of a flocculating ion or the active ion, greater will be its coagulation, or we can say flocculation power. That means if our sole is positive, let our sole is positive, at the time if I am using any electrolyte which have Na plus, if my sole is positive and if I am using an electrolyte NaCl or MgCl2 or Na2SO4. So from these electrolytes which have greater power, because the sole is positive means the negative ion will act as active ion. So here the negative ion is Cl negative, which have one negative charge. Here also it have one negative charge, but sulfate have two negative charge. So which can be more actively do the flocculation? That is sulfate ion, which have greater charge. We can say greater valency. So what it is explained here, according to Hardy-Schulze rule, greater the valency of the flocculating ion, greater will be its flocculation power, or we can say coagulation power. Let us take an example. If our sole is negative charged, let our sole is negative charge. So which charge will be the at the time the positively charged ion will be the active. That means it should be opposite. If our sole is negative, then the active ion should be positive. Now here there are some examples of positively charged ions, that is Al3+, Ba2+, Na+. Now from this, which one have greater valency? Definitely Al3+, that is it have 3+ charge. Ba2+, it have 2+ charge and it has 1+. That means +3 charge, +2 charge, +1 charge. Which have the greater valency here? That is +3. +3 is the greater valency. So we can say that greater the valency of the active ion, greater will be the flocculation power, or we can say coagulation power. If our sole is positive sole, this is our sole that is positive. So what will be the charge on the active ion? The active ion should be of negative charge. That means opposite. So here are some negatively charged ions. From this, which have the greatest charge, that is here this one have -4 charge, it have -3 charge, the sulfate have -2 and this chloride have -1. So which one have highest charge here? That is -4. That is negative is not considered here. The 4, we can say the 4 is highest. So greater negative charge is for this ion. So we can say it have the greatest power, or we can say it coagulate the sole, positive sole, very easily. So this is greatest, then this and this. So that is the Hardy-Schulze rule says. Now one question we will be going to discuss here. Which of the following is most effective in coagulating ferric hydroxide sole? As we have already discussed, ferric hydroxide sole is one of the positive soul. It is the positive soul. So what will be the charge of which charge will causes the flocculation? If the soul is positive, then negative ion will be the active ion, or we can say flocculating ion. Always it should be opposite. Now tell me which is the negative ion in first case, that is KCl. The negative ion is Cl minus. In the case of FeCl3, which is the negative ion? That is Cl negative. It's chloride ion. In the case of Na2SO4, it is sulfate ion, that is SO4 2 minus. Now from these ions, which have the greatest valency, that is sulfate ion, because it have 2 minus 2 charge and these have minus 1 charge. So sulfate ion have greater valency, therefore it will be a effective active ion. So the answer for this question is this. Which one? That is, this is the answer. So in the exam you will be getting such type of questions. For this you need to consider the charge on the active ion and answer it on the basis of it. So what is the flocculation or the coagulation value? It is the minimum concentration of an electrolyte which is required to cause the coagulation or flocculation of a sol. This is called as coagulation or flocculation value. It is usually expressed in millimoles per liter. Let us see some examples. The values, coagulation value. In the first, that is for the coagulation of negatively charged sol. That means if the sol is negative, what will be the charge on the active ion? The charge should be the positive charge will be the, you can see here, the cations are the active ion. So coagulation value you can check here. For H plus ion it is this value. For this and this. So which have the lowest coagulation value? That is this value. That means aluminium having plus 3 charge, that is the greater valency, have coagulation value less. That means lesser the coagulation value, greater will be the greater will be the effectiveness for coagulating the sol. And in the second case we can say if the sol is a positively charged sol, then the active ion will be negatively. You can see the active ions are negative, that is anion. When you compare the coagulation value in this, which have lowest value, this is the lowest value, and that is for this case, this example. And this have a highest valency, therefore it have lowest coagulation value. So from this what we can conclude that the ion which have highest valency, they have lowest coagulation value. That means a small quantity of that electrolyte is enough for the coagulation of a particular sol. Next topic in this, that is protection of colloids. Lyophilic colloids have a unique property, that is to protect the lyophobic colloids. As we have already discussed, lyophilic are more stable than lyophobic. So it have a tendency to protect the lyophobic colloids. And how it protect the lyophobic colloids? By forming a layer around it. You can see the lyophobic particles is surrounded by lyophilic particles. That means lyophilic particles are protecting the lyophobic particles. So thus lyophilic used for this purpose is called as protective colloids. That means when we add small amount of electrolyte, it will not, the lyophobic will not get coagulate, because the outer layer, that is a layer of lyophilic sol, is protecting them. from electrolyte. Coagulation of lyophilic soul. As we have already discussed, lyophilic souls are quite stable. So what are the two factors responsible for the stability of lyophilic colloids? That are charge, that is the charge, and the solvation of particles. There is a greater interaction between the particles, between the dispersed phase and dispersion medium, and because of the charge they have greater stability. So when these factors are removed by adding electrolyte or by adding suitable solvent, causes the coagulation. As we have already discussed, it is not easy to coagulate lyophilic souls because they are quite stable. So let us summarize. In this we have learned about what is coagulation and what are the means by which the coagulation takes place. That is by electrophoresis, by mixing of opposite charged souls, by boiling, excessive of boiling, by persistent dialysis, that is the removal of electrolyte from the soul, by addition of suitable electrolyte. In that topic we have learnt about coagulating ion, which is also called as flocculating ion or active ion. Hardy-Schulze rules, which say that greater the valency of the active ion, greater will be the flocculation power. Then what is the flocculation power and the flocculation value? We have also discussed about coagulation of lyophilic soul and protection of colloids. So these are the different topics which we have discussed in coagulation. So in this way we finished coagulation. But one more question arises here. What is the difference between coagulation and peptidization? That will be going to discuss in the next video. So thank you everyone.